Okay, I know you have studied different type of signal in module, signal and system now. So we will briefly look into what you have studied in previous semester. Signals are classified into following categories: continuous time and discrete time signal, deterministic and non-deterministic signal, even and odd signal, periodic and aperiodic signal, multi-channel and multi-dimensional signal, continuous valued and discrete valued signal. So do you remember what you have studied?
Yes, sir.
Okay, yes.
Yes, sir.
At least say yes.
Yes, sir.
Yes, Labdalu.
Remember.
Now, firstly, continuous time and discrete time signal. From the name itself, continuous time signal Zevdadi, the signal will be continuous. So figure A is a continuous signal. Rock Pidumosh signal, but still it is continuous. So this one is known as continuous time signal. And here you have a discrete time signal and representation x of n. And in the x-axis you have n, anabiochin x of t and a t. So this is continuous at the instant time. This is discrete at the instant time, and time is represented by letter n. And your signal is represented by x of n, where continuous time signal is represented by x of t. A signal is said to be continuous when it defined for all instant of time. A signal is said to be discrete when it is defined only at discrete instant of time. And figures are shown out here. Now, we have other type of signal, that is deterministic and non-deterministic signal. So when we say deterministic signal, that is signal which we can draw the function, which we can write the function. Ani signal na function based on x of t is equal to sine t or cos t is a that is that type of signal is known as deterministic signal. So if signal is if you can't draw the conclusion of the signal, and if you can't draw the equation, that signal is known as non-deterministic signal. So ana signal rock with the so you can name the function of signal sin t membe cos t membe. So therefore such type of signal is known as non-deterministic signal. A signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time, or signal which can be defined exactly by mathematical formula are known as deterministic signal. So which is opposite to deterministic signal is non-deterministic signal. A signal is said to be non-deterministic if there is uncertainty with respect to its value at some instant of time. Non-deterministic signals are random in nature, hence they are called random signal as well. Random signal cannot be described by mathematical equation. They are modeled in probabilistic term. Now again you have even and odd signal. A signal is said to be even when it satisfies the condition x of t is equal to x of bracket open minus t bracket close. Chiriduga, do you remember what is even signal and odd signal?
Yes, sir.
Is sin t even or cos signal?
Odd signal, sir.
Yes,
Odd
Odd.
odd emotion. So example are t2
sir.
odd signal sin t, cos t the even signal. T2, T4, cos t are example of even signal. Now let's prove whether the T2 is even signal. So given x of t is equal to T2, and x of bracket open minus t is equal to now we are giving minus t and adubati minus t 2. Mosh, which is equal to your x of t. Hagoiga gadi proof pega.
Maybe t square, t is t
And
square.
Mosh, first x of t is equal to t of t. We equate this one. Now you have x of minus t. So x of minus t. So for this one, so we can give minus t2. And this one is equal to t2. So this t2 is nothing but x of t minus t2 is nothing but x of minus t. So therefore, this is even signal. And you can prove cos of t, tuga. Cos of t proof payme, tuga. And tell me whether cos of
Sir, what function is sir?
Gadebe.
Maybe it is
T
t square,
this.
sir.
Gadebe
T square.
Virgin even in sir. T2 virgin the odd sir. Minus of
Yes,
x
sir.
of t sir.
Gadebe otte. True be
Because x of t is t2 sir.
t2 member t square also.
Yes, sir.
Sir, t2 select dila.
Where this t is fundamental time period and fundamental frequency is given by 1 by t. So if it does not satisfy this condition, then signal is said to be aperiodic. So you should know how to find the fundamental period, fundamental frequency, and fundamental time period from the given signal. T naught and is to find many, you have already studied most signal in the system. Above signal will repeat for every time interval t naught. This signal will repeat every after time interval t naught. Hence, it is periodic with period t naught. Signal which does not repeat every time interval t naught is aperiodic signal. Now, discrete time signal. A discrete time signal, which is represented by x of n, is a function of independent variable that is an integer. Discrete time signal is represented by graphical method. Another alternative method which is more convenient to use are functional representation. X of n equal to 1 for n equal to 1 and 3. X of n equal to 4 for n equal to 2, 0 elsewhere. Then we can represent in tabular representation where n and x of n minus 2, minus 1, 0, 1, 2, 3, 4, 5, minus 2 na 0, minus 1 na 0, 0 na 1, 1 na 1, 4, 1, 0, 0. This is the signal representation. And we can represent signal in sequence representation. X of n 0, 0, 1, 4, 1, 0, 0. This arrow mark shows origin of the signal. Mosh, do you remember?
Yes, sir.
Yes, sir.
Okay. If you remember, that is very good. Now let's see some of the elementary discrete time signal. So you might have already studied this type of signal, elementary discrete time signal. A unit sample signal, which is denoted by how we read del
Del of n.
del of n is defined by del of n is equal to 1 for n equal to 0, 0 for n not equal to 0, and signal is represented by this one anyway. So you have signal only at n equal to 0, 0 for rest of the time period. And you have a unit step signal which is denoted by u of n and defined as 1 for n greater or equal to 0, 0 for n less than 0. Anna 0 Anna Thomiga, can you read this one? 0 1 2 3 4, so it will go to infinity. So the signal start from 0 till it's go to positive infinity. Below 0 there will be no signal for unit step signal. Chiriduga.
Chiridula.
Yes, sir.
Chirivachin. Again you have a unit ramp signal which is denoted by URN. For n equal to n, for n greater or equal to 0, 0 for n less than 0. 0 lay, so it is going to start. RAM zumbeli unit RAM functions in So as you keep on giving the substitution for n, 1, 2, it will keep on increasing anyway, RAM thing. So it looks like a RAM. And finally, we have exponential signal, which is a sequence of the form x of n equal to a to the power n for all n. And here is the exponential. An exponential, this is positive exponential where a is greater than 1, and you have a negative exponential where your a is a range from greater than 0, less than 1. And similarly, you have exponential where your a is less than -1, and you have exponential where a range from -1 to 0. This is a type of exponential signal. Now, this one, signal manipulation, we are going to study in Unit 2, but let's introduce just now. Atich introduce big. Can you read the slide?
Yes, sir.
Transformation.
Da gachila megata matuk gachachil habbe. And a transformation of independent variable imati. Signal manipulation is transformation of independent variable. So when it says transformation of independent variable, it means the amplitude member time the change beyond the most independent variable the time imivati. A signal x of n may be shifted in the time n by n plus k, where k is the integer. Now, shifting of signal will depend on value of k. If the k is positive integer, the time shift result in delay of the signal by k unit of time. If k is negative integer, the time shift result in advance of signal by k unit in time. Hagoi gani ane two sentence.
Goila.
Yes, sir.
Positive imagine gachi biono.
Delay doing.
Delay below.
Ani gadi jong ani chigi logic hagoi ga. Now, for example, your time bomb Jin biwachin 12 minutes na blast joni me mosh me ime blast joni me chegi me. I'm thinking how to explain you in the anigi. You have one signal, Anna. The question digati jayega. Anna.
Time bomb equal yes.
Meme Anna signal chiduga the most. Can you see the signal?
Yes, sir.
Yes,
Yes,
sir.
sir.
Can you do? Asimi.